Every modern artificial intelligence system runs into the exact same operational ceiling. They are constrained entirely by the availability of data that actually reflects the problem they have to solve. For machine vision, the gap between a clean dataset used in a laboratory and a dirty dataset required for the battlefield is severe. A bounding box drawn over a clearly visible vehicle in daylight represents a controlled environment, but actual combat introduces thermal artifacting and digital distortion that consistently confuse standard algorithms. You cannot scrape this specific visual reality from the internet. You also cannot synthesize a convincing substitute in a laboratory environment. It only exists where systems are actively operating in conflict zones. Training these models requires millions of examples of actual edge cases. Algorithms need to process the exact thermal signatures of active machinery, targets obscured by varied weather conditions, and active camouflage breaking up a vehicle's silhouette against a tree line. Without repeated exposure to these hard cases, commercial models collapse. A detector trained on clear imagery simply stops working the moment a target is dragged onto a muddy road or parked beneath a dense forest canopy. Acquiring this proprietary adversarial dataset is the primary barrier preventing the deployment of functional autonomous systems in modern conflict. To counter rapid technological shifts, Ukraine has established an aggressive operational goal, equipping all frontline drones with onboard machine vision and AI. The environmental driver forcing this mandate is relentless Russian electronic warfare and signal jamming across the entire combat zone. A drone that relies on a live radio link or a clear GPS signal will miss its target when those connections are severed. Onboard autonomy allows the system to navigate and lock onto targets using only its visual sensors, completely bypassing external signal interference. To train those visual sensors, Ukraine controls an asset unmatched anywhere in the world. They possess millions of annotated frames captured across tens of thousands of real combat sorties. Instead of treating this massive volume of combat footage as a byproduct of the war, the Ministry of Defense is actively structuring it as a sovereign export product. The intense pressures of electronic warfare have inadvertently converted the Ukrainian frontline into the world's most valuable AI training ground. This creates a severe structural paradox: how a government shares hypersensitive military footage with foreign defense contractors without risking massive data exfiltration. The solution is the highly secure BraveOne data room, built jointly by Ukraine and U.S. firm Palantir. Over 100 developers operate inside. Crucially, the raw training data never leaves this environment. Companies only export their finished, fine-tuned AI models back to military edge devices. This architecture essentially establishes a strictly regulated two-sided market. The currency of this market is straightforward. Foreign and domestic firms get access to verified combat data, paying for that access by handing finished AI models back to the military. By utilizing this data room architecture, Ukraine solves the security bottleneck. They are actively monetizing their dataset to harden algorithms, while maintaining absolute control over the raw operational footage. The algorithms trained inside the data room are immediately deployed into an operational system called Avengers. Avengers is a centralized platform designed to process massive volumes of incoming video from drones and fixed cameras, automatically classifying and tracking hostile targets in near real time. According to the Ministry of Defense, this platform currently flags approximately 12,000 enemy units every single week. These automated detections feed directly into Veja, a module inside Delta, the military's situational awareness system. A human operator confirms or corrects the system's flag detections. This interaction creates a permanent feedback loop. Every correction flows back into the data room as a newly labeled example. Avengers functions as a self-sustaining data engine. Every field deployment automatically generates the labeled training material for its own next iteration. The most visible payoff of this training pipeline is the deployment of specialized autonomous interceptors, actively neutralizing incoming threats, specifically the Shahed attack drone. Russian Shahed launches are increasing by roughly 35% month over month, requiring a highly scalable and resilient defense architecture. One autonomous interceptor model, developed by Maxon Systems, plugs directly into the national radar network to identify incoming targets at long range. Human involvement in this process is strictly limited. The operator only selects the target and authorizes the engagement. The software then takes over. It navigates and executes the terminal intercept entirely without manual piloting, effectively automating 95% of the kill chain. Parallel applications of these vision models are already appearing in ground combat. Units like the K2 Brigade are deploying AI-controlled turrets capable of defeating incoming fiber optic drones that are physically immune to standard jamming. Achieving near-total autonomy in a highly jammed environment is the direct, quantifiable result of training on the extreme visual edge cases captured within the Avengers dataset. Ukraine is now actively converting this wartime data collection capability into permanent defense industrial infrastructure. They are expanding the financial scope of this ecosystem through initiatives like BraveTech EU, backed by a €50 million joint seed fund. This expansion is supported by bilateral agreements like the Brave Germany partnership, which is specifically focused on co-developing unmanned systems and AI. Major allied defense technology players, including Palantir and Shield AI with its HiveMind autonomy stack, are already operating deep inside this ecosystem. By leveraging its data monopoly, Ukraine is forcing the entire Western defense AI sector to utilize its testing infrastructure to validate their models. As algorithmic architectures continue to commoditize, the specific origin of a training set determines whether a model can actually navigate the chaos of a live environment. Proprietary, hard-to-collect adversarial data is the only variable separating a concept that works in a lab from a system that reliably executes in the rain at 2 in the morning. The Avengers lab structure offers a highly replicable template. Trading access to a unique dataset in exchange for the finished model is a framework that other capital-poor, data-rich sectors like healthcare or logistics could immediately copy. Furthermore, the deployment of these systems proves that governance debates over meaningful human control and autonomous targeting are no longer academic. The technology is already actively deployed in the field. While drone hardware continually captures public attention, the foundational, verified dataset is the true strategic asset, dictating the capabilities of modern warfare.